In this video, we'll learn how to solve real-world linear equation situations, and we'll learn how to interpret the slope of these situations. So to begin, let's read through this problem together. It says, a company purchases a copier for $12,000. The spreadsheet, so this little table over here, shows how the copier depreciates over an 8-year period. So the first part says, write a linear function to represent the value v, so those are going to be our y values, of the copier as a function of the number of years t. So that means that's going to function as our x value there. So the first thing we need to do is we need to write this equation and we need to get it into slope-intercept form. So just like before, we always start in point-slope form and then we rewrite it into slope-intercept form. And to do so, we need to pick some points and we need to identify what our slope is. Now it doesn't matter which points you pick to identify your slope. I'm just going to pick these two here. So I'm using the points 0, 12,000 and the point 1, 10, 750. So I'm going to calculate the slope of this line by utilizing the points in the table. And again, you can pick any pair of points that you would like. So we're going to start here. Remember, it's y2 minus y1 over x2 minus x1. So we start that calculation with 10,750 minus 12,000 divided by 1 minus 0. So we end up with negative 1250 over 1, which we can simplify just to be negative 1250 if we want. So now that we have our slope, we can move forward and write our equation. And remember, to write our equation starting in point-slope form, we need to pick a point. I'm going to pick this point here because I think 0 makes it look like it would be a pretty easy problem to solve. So we do y minus our y-coordinate of 12,000 is equal to negative 1250 times in parentheses x minus 0. Well, I can distribute this negative 1250, so this just becomes y minus 12,000 is equal to negative 1250 and then just an x and the rest is 0. We then add 12,000 to each side. So we end up with y is equal to negative 1250x plus 12,000. Now, the last thing that this problem asked us to do is to write this as a function using v and t. So once we have this equation written, I'm going to go in and I'm going to replace this y with v of t, because that's the function name. I'm going to replace x with t. So we have the function v of t is equal to negative 1250 plus 1250x plus 12,000. So that's our new function. So that's what you should have for the function part. This next piece says, interpret the slope of the graph in the context of the problem. So you can see the slope in two different places here. We calculated the slope here, and we can see the slope as the coefficient of x in our function. So this negative 1250 over 1 represents our slope. And the easiest way to interpret that is to first write it as a fraction so that you have a numerator and a denominator. So you'll see I'm leaving it here in the fraction form before I simplified it. And then what I recommend next is looking at your table. Remember, slope is calculated by rise, which is your y values, over run, which is your x values. So to figure out what the units in your top of your fraction are, you go to the y values here, because that's your rise. And you can see that all of these are dollars. So what this is really saying is you go down $1,250. That's what our numerator is telling us. It's talking about a cost, and it's saying it's decreasing or going down by $1,250. Then if we look at our x values here, these represent years. So this bottom part of a 1 represents 1 year. So what our slope is really telling us here, if we read this entire fraction as is, it's saying that over time, that value, the copier's value, is going down by approximately $1,250 per 1 year. So use the fraction here to help you and use the units that you see in order to be able to interpret what that slope is actually trying to communicate to you. So problem number 2 says that this graph over here shows the distance, so you can see that the y value is distance, that asteroid 2012 DA14 travels in x seconds. So we can see that going on. Our y value is distance, our x value is time in seconds, and we can see that represented in the graph. So this first part says write a linear equation in slope-intercept form for this situation. So in order to write a linear equation, we need a point and a slope. And we can clearly see that we have one point here of 5, 24, and it kind of looks like they don't give us the slope and they don't give us a second point. But if you look very closely, you can see that there's a first point here at 0, 0. So we actually have 2 points from this picture. We can see the graph starts at 0, 0 and then continues on to the point 5, 24. So what we can do from here is we can write this equation by finding the slope to begin with. So remember, we have x1, y1, x2, y2, and we take 0 minus 24 over 0 minus 5. So we have negative 24 over negative 5, which that can simplify because we have negative over negative to be 24 over 5, or you can utilize your calculator here to divide that out. So 24 over 5 is about 4.8. So from here, what we can do is we can take this information and we can write an equation into point-slope form and convert it into slope-intercept form. So I'm going to pick the point 0, 0 because to me that's a really easy point to plug into point-slope form. So we have y minus 0 is equal to 4.8 parentheses x minus 0. Distribute that, so I have y minus 0 is equal to 4.8x plus 0. I can drop those zeros because zeros represent nothing, so my equation is y equals 4.8x. So I now have a function to represent this graph. Now, the second thing I need to do in part B is I need to interpret this slope. And again, let's take a look at the fraction. So I'm going to pull this part down here. And so we start off with 24 over 5. And if you think about how that slope was calculated and you look back, remember it's rise, so our y values, which have a unit of miles, so it's 24 miles over our x values, our runs, which are written in seconds. So you can interpret that first slope if you want, and what this is saying is that this asteroid travels 24 miles in 5 seconds. But we did simplify it here to be 4.8. So we can actually translate that. So we have 4.8 and just put it over 1 because that's really what 4.8 is 4.8 divided by 1. And if we apply those same units here, what this slope is really telling us is that this asteroid is traveling 4.8 miles per 1 second. So you can write that out. You can say the asteroid is traveling 4.8 miles per 1 second. So we can see that all written out in our fraction and by utilizing the units that are found here in our graphs. Now, the last question here says an asteroid came within 17,200 miles of Earth in February 2013. About how long does it take the asteroid to travel that distance? So what they've given us here is a set of miles. So I have 17,200 miles. And before I look at and utilize my equation, where I have y equals 4.8x, I need to think about which variable, y or x, that 17,200 might represent. And if I take a look up here at my graph, what I notice is that miles is on the y-axis. So what this is really telling me is that this 17,200 represents the y value. So we can take this value and we can substitute it in for y and find x, which will tell us after how many seconds that asteroid traveled that distance. So if we take our original equation and we plug that in, so 17,200 is equal to 4.8x. And then we need to solve for x, and we're multiplying x by 4.8, so we're going to take 17,200 and divide it by 4.8. So we divide 4.8 on each side, and we find that x is equal to approximately 358.33 repeating seconds. So we find that it would take approximately 358.33 repeating seconds to travel that 17,200 miles.